Ashe. My dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic Applied Electronics Information session produced by our esteemed elder Baba Jelani Bamani Dembe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished Baba Jelani Bamani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the Ohm's Law. Ohm's Law is a fundamental concept in electronics that is essential for applied electronics technicians to understand in order to successfully design, build, and troubleshoot electronic circuits. Named after the German physicist George Ohm, Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance of the conductor. In simpler terms, it can be expressed as the equation I equals V divided by R, where I is the current in amperes, V is the voltage in volts, and R is the resistance in ohms. Understanding Ohm's law is crucial for applied electronics technicians for several reasons. Firstly, it allows them to calculate the amount of current flowing through a circuit given the voltage and resistance values. This is important in determining whether a circuit can handle the amount of current it is expected to carry without overheating or failing. By using Ohm's law, technicians can ensure that the components in a circuit are properly rated and the circuit is designed to operate within safe limits. Secondly, Ohm's law is essential for troubleshooting electronic circuits. When a circuit is not functioning correctly, technicians need to be able to determine whether the issue is related to the voltage, current, or resistance in the circuit. By applying Ohm's law, technicians can calculate the expected values of current, voltage, and resistance at different points in the circuit and compare them to actual measurements to identify the source of the problem. Additionally, understanding Ohm's law is crucial for designing and building electronic circuits. By knowing the relationship between voltage, current, and resistance, technicians can calculate the values of components such as resistors, capacitors, and inductors needed to achieve a desired effect in a circuit. For example, when designing a voltage divider circuit, technicians can use Ohm's law to calculate the resistor values needed to divide the input voltage to a specific output voltage. Furthermore, Ohm's law is also important for understanding the behavior of different circuit elements. For instance, in a simple resistor circuit, Ohm's law can be used to determine how changing the resistance value affects the current flowing through the circuit. By manipulating the values of voltage, current, and resistance in a circuit, technicians can study the effects of different components on the overall circuit performance and optimize the design for a specific application. Applied electronics technicians need to have a solid understanding of Ohm's law in order to effectively work with electronic circuits. By knowing the relationship between current, voltage, and resistance, technicians can calculate values, troubleshoot issues, design circuits, and understand the behavior of different components in a circuit. Ohm's law serves as the foundation for more advanced concepts in electronics and is essential for anyone working in the field of applied electronics. Therefore, technicians should take the time to study and master Ohm's law to ensure their success in the field and to create safe and efficient electronic systems. Ohm's law is a fundamental principle in the field of electronics that states the relationship between voltage, current, and resistance in an electrical circuit. It is named after the German physicist George Simon Ohm, who first formulated this law in the early 19th century. Ohm's law is essential for applied electronics technicians to understand because it provides them with a framework to analyze and predict the behavior of electrical circuits. One of the key aspects of Ohm's law is the mathematical relationship between voltage, current, and resistance. The law states that the current flowing through a circuit is directly proportional to the voltage applied across the circuit and inversely proportional to the resistance of the circuit. Mathematically, Ohm's law can be expressed as V equals IR, where V is the voltage across the circuit, I is the current flowing through the circuit, and R is the resistance of the circuit. Understanding Ohm's law allows technicians to accurately calculate the values of voltage, current, and resistance in a circuit. This knowledge is crucial for troubleshooting electrical problems, as technicians can use Ohm's law to identify the source of an issue and make necessary repairs. For example, if a circuit is not functioning properly, technicians can use Ohm's law to determine if the voltage and current values are within the expected range, and if not, they can pinpoint the component causing the problem. In addition to troubleshooting, Ohm's law is also essential for designing and building circuits to meet specific requirements. By applying Ohm's law, technicians can determine the optimal values of voltage, current, and resistance for a given circuit design. This allows them to ensure that the circuit operates as intended and meets the desired performance criteria. Whether it is designing a simple LED circuit or a complex electronic system, the knowledge of Ohm's law is indispensable for applied electronics technicians. Moreover, Ohm's law serves as a foundational concept in electronics and electrical engineering. It provides a basis for understanding more complex topics such as power, energy, and circuit analysis. By grasping the principles of Ohm's law, technicians can delve into advanced topics like Kirchhoff's laws, network theorems, and impedance matching with confidence. These advanced concepts build upon the principles of Ohm's law, allowing technicians to tackle more challenging problems in their work. Another crucial aspect of Ohm's law that technicians need to understand is its application in ensuring the proper functioning and safety of electronic devices and systems. By following Ohm's law, technicians can calculate the power dissipation in components, determine the voltage drop across resistors, and assess the current carrying capacity of wires and connectors. This knowledge is essential for preventing circuit overheating, component failure, and electrical hazards that could pose risks to both the equipment and personnel. Ohm's law is an essential concept for applied electronics technicians to master. By understanding the relationship between voltage, current, and resistance in an electrical circuit, technicians can analyze, predict, and troubleshoot circuits effectively. This fundamental knowledge is crucial for designing and building circuits, as well as for grasping more advanced topics in electronics and electrical engineering. In short, Ohm's law is the cornerstone on which the field of electronics is built, and it is imperative for technicians to have a firm grasp of this fundamental principle in their work. Ohm's law is named after the German physicist George Simon Ohm, who first formulated it in the early 19th century. The law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance of the conductor. Mathematically, Ohm's law can be expressed as V equals I times R, where V is the voltage, I is the current, and R is the resistance. For applied electronics technicians, Ohm's law serves as a foundational principle that is essential for understanding the behavior of electrical circuits. It provides a quantitative relationship between voltage, current, and resistance, which allows technicians to predict how a circuit will respond to changes in these parameters. By applying Ohm's law, technicians can calculate the voltage, current, or resistance in a circuit based on known values of the other two parameters. One of the most important applications of Ohm's law for applied electronics technicians is in circuit analysis and design. When designing a circuit, technicians need to ensure that the components used have the proper values of resistance to achieve the desired level of current flow and voltage drop. By using Ohm's law, technicians can calculate the resistance needed for a specific application based on the desired current and voltage levels. In addition, Ohm's law is crucial for troubleshooting electronic systems. When a circuit is not functioning as expected, technicians can use Ohm's law to diagnose the problem and identify the faulty component. By measuring the voltage and current at various points in the circuit, technicians can calculate the resistance and determine if it is within the expected range. If the resistance is too high or too low, technicians can then locate and replace the faulty component. Furthermore, Ohm's law is essential for ensuring the safety of electronic systems. By understanding the relationship between voltage, current, and resistance, technicians can calculate the power dissipated in a circuit and ensure that it does not exceed the maximum ratings of the components used. This knowledge is crucial for preventing overheating and electrical failures, which can lead to damage or injury. Overall, a solid understanding of Ohm's law is vital for applied electronics technicians to effectively design, build, and maintain electronic systems in a variety of industries. For example, in the telecommunications industry, technicians use Ohm's law to design and troubleshoot communication networks, ensuring reliable transmission of signals. In the manufacturing industry, technicians apply Ohm's law to control the flow of electricity in automated systems, optimizing production efficiency. In the automotive industry, technicians use Ohm's law to design and test electrical systems in vehicles, ensuring safe and reliable operation. Ohm's law is a fundamental principle that governs the behavior of electrical circuits and is crucial for applied electronics technicians. By understanding the relationship between voltage, current, and resistance, technicians can effectively analyze, design, and troubleshoot electronic systems in various industries. Ohm's law provides a powerful tool for technicians to predict and control the behavior of circuits, ensuring the safe and efficient operation of electronic systems. Applied electronics technicians are crucial in the design, troubleshooting, and maintenance of electronic systems in various industries. To excel in their roles, technicians must possess a strong understanding of fundamental concepts, such as Ohm's law. Ohm's law is a basic principle in electronics that relates the voltage, current, and resistance in a circuit. By applying Ohm's law, technicians can efficiently diagnose and troubleshoot issues, design effective circuits, optimize system efficiency, ensure safety, and perform routine maintenance. One of the key areas where technicians rely on Ohm's law is troubleshooting. When an electronic system malfunctions, technicians use Ohm's law to analyze voltage, current, and resistance values to pinpoint the faulty component or circuit. By comparing the expected values based on Ohm's law with the actual measurements, technicians can quickly identify the root cause of the problem and implement the necessary repairs. This ability to troubleshoot effectively not only saves time, but also minimizes downtime and reduces repair costs, making technicians more efficient and valuable in their roles. In circuit design, Ohm's law plays a critical role in determining the values of components such as resistors and capacitors. By applying Ohm's law equations, technicians can calculate the required resistance or capacitance to achieve the desired voltage or current levels in the circuit. This ensures that the circuit operates correctly and efficiently, meeting the performance requirements of the system. Additionally, understanding Ohm's law helps technicians select the appropriate components to prevent overloading or underutilization, ultimately leading to a more reliable and cost-effective design. Efficiency is another aspect where Ohm's law proves to be indispensable for applied electronics technicians. By utilizing Ohm's law, technicians can optimize electronic systems to operate at their maximum efficiency. This involves calculating the power dissipated in different components, analyzing voltage drops across resistors, and ensuring that currents flow within specified limits. By fine-tuning the system based on Ohm's law principles, technicians can reduce energy consumption, minimize heat generation, and enhance overall performance. This not only benefits the operational efficiency of the system, but also contributes to sustainability and cost savings in the long run. Safety is a paramount concern for applied electronics technicians, especially when dealing with high-voltage or high-current systems. Ohm's law provides essential insights into the relationship between voltage, current, and resistance, enabling technicians to calculate parameters such as power dissipation, potential drop, and current flow. By applying these calculations, technicians can identify potential hazards such as overheating, short circuits, and voltage spikes, allowing them to implement appropriate safety measures. Understanding Ohm's law is thus crucial for preventing accidents, safeguarding equipment, and ensuring the well-being of both technicians and users of electronic systems. Lastly, maintenance of electronic systems relies on Ohm's law for monitoring and testing components. By employing Ohm's law formulas, technicians can assess the health of resistors, capacitors, and other components by measuring their resistance, capacitance, or impedance values. This helps identify signs of wear and tear, degradation, or potential failures, enabling technicians to proactively replace or repair components before they lead to system malfunctions. Routine maintenance based on Ohm's law principles helps prolong the lifespan of electronic systems, reduce the risk of unexpected breakdowns, and uphold the reliability and performance of the equipment. In conclusion, a comprehensive understanding of Ohm's law is indispensable for applied electronics technicians in various aspects of their work. By leveraging Ohm's law for troubleshooting, circuit design, efficiency optimization, safety assurance, and maintenance tasks, technicians can effectively fulfill their roles in designing, maintaining, and troubleshooting electronic systems. As technology continues to evolve and electronic systems become more sophisticated, the relevance of Ohm's law remains paramount for technicians to meet the demands of modern industries and deliver high-quality solutions. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. I am your royal narrator, Queen Magical Melanin. Here's a special message from our esteemed elder Baba Jelani Bhumani Dambe, the brilliant mind behind Majestic Mind Matters University, to all applied electronic technicians. Your participation with Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for your valuable applied electronics information to aid to your success with this basic applied electronics information session titled Introduction to the Ohm's Law. Stay woke. Ashe.